Hello. We are now looking at Chapter 1, Introduction to the World of Computers. We're going to dive right into the readings. Your book is Understanding Computers. At this point, if you do not have a book, you need to get one very soon. So, in Chapter 1, we've got some different learning objectives. We want to accomplish about 10 or 11 things with this chapter, starting with explaining why it's essential to learn about computers. We want you to be able to define a computer and describe its primary operations, understand some important milestones in computer evolution, identify the parts of a computer from looking at them. And for many of you, this will be the first time you may have seen the guts of a computer, and we're going to talk through those a little bit. Define software, understand how it is used, and understand how it controls the computer. And then after that, we've got a couple more we want to look at. We want to understand the 6 basic types of computers. And now in this lecture, we're just going to hit that at a top level. We also want to explain what a network is, what the internet is, and what the World Wide Web is. Now, these broadly are networks, but we'll talk about the differences between those. And after that, we'll look at how to access a website, what that URL means, what a URL is. And then finally, we'll discuss kind of the societal impact of computers. So we have a pretty long laundry list of things we want to accomplish in this chapter. So with that said, if you take a look, the chapter is about 70 printed pages. We're not going to spend enough time to cover every single aspect of the book. So you're definitely going to have to do those readings, okay? So let's get to an overview of just this chapter. Now, in the chapter, we're looking at a couple things specifically. What are computers? How do they work? How are they used? Now, you may feel as if you know the answers to this already. You're obviously viewing this on a computer. You've used it before, and it's nothing big or new. It's not a marvel of technology. It's something you've grown up with your whole life. So that question is something we're going to dig into and look at computers in a different way. Also, computer terminology. We are going to demystify the acronyms, the funny words, the things that you have heard around you but never quite understood when it comes to computers. We're going to look at the history of computers. Every good introduction course should talk about the history of the things that you're understanding. This is an introduction to computers in essence. It's called basic computer literacy, but it's really an introduction to computers. After that, we're going to look at the basic types of computers in use today. Now, in this chapter, we're just going to look at the basics of these types. I'm going to tell you the type, tell you a little bit about it, but we're going to dig into these later into the book in detail. So right now, it's going to be I'm more interested in you understanding what the words mean, not necessarily understanding how everything we talk about works. That's for the rest of the course. And then finally, the societal impact of computer. And that, I think, is what you're seeing unfold around you. So let's jump into it. So computers in your everyday life. The first question is, why do we need to learn about computers? Well, the thing about it is, computers are they're not always presented to you in a way that looks like a computer. They're pervasive. We also use the phrase ubiquitous. This is computers that are so hidden, so disguised, so wrapped up that they're actually an integral part of our lives, and we don't even know we're working with computers. So computers are pervasive. They're everywhere. Right now, you probably have at least 2 computers right next to you. You of course you recognize your laptop as a computer, but you've got computers all around you and you don't even know it. The next reason is basic computer literacy is a hallmark of a professional. And you've come to college not just to get a degree. Of course, I hope your number one reason to come to college is to get a degree, not to find a wife or a husband, not to join a Greek letter organization. But I hope you came to college to get a degree, and you'll use that degree to increase your wealth, get a job, and understanding how a computer works and how it works is going to pay off in the real world. My job in the Center for Career and Professional Development, that's the place where I work with employers, and it's my job to help students get jobs when they graduate. And that is accomplished through the most part by using a computer. So basic computer literacy, this is not just a skill to help you word process better. It is a skill to help you build a framework for the infrastructure of education, the infrastructure of learning, the infrastructure of communication. At this point, it is built on this foundation of computer literacy and knowing how to use technology. So computers now are different than they were before 1980. 1980 was kind of a watershed moment. In the 1970s, 60s, and all that before then, computers were large. And when I say large, I don't mean, that very big tower on the floor under your desk right now. I mean, large as in football fields. A entire floor of a building would be dedicated to one computer. They were big. And not only were they big, they were so expensive that very few people had access to them. A computer was used for very, very complex things back then, and things that wouldn't be complex today were complex with that era of technology, and they were exclusively just for computers. You had to sign up to get time to use the computer, and you had to be a computer programmer. That's where the mystique and all the stereotypes around computer programmers came from this time before the 1980s, where you had to be a very math-oriented, a very science-oriented person and spent a great deal of your life working on these computer programs, and you'd had to sign up to use a computer. So what made the 80s so important was that in 1980s, we went from these, I'm going to call them macro computers, these huge computers, room-sized computers, to what we call now a microcomputer. Now, a microcomputer is what you are viewing this on. It's a computer that fits on a desk, fits in your lap. So that's a microcomputer. The difference is that the microcomputers, instead of being big, large, expensive like before the 80s, now these are inexpensive. They're personal computers, and they're even faster. The technology had progressed to where that small laptop that you're using in 1995 is 100 times, 1,000 times faster than the computer that filled up an entire football field 30 years earlier. So when we're talking about the computers in your life, it has evolved. Computers have moved from a state where they weren't in your life. In the 1970s, no one had a computer. The closest thing anyone had to a computer was a calculator. But after 1980, and we're really talking about like the Apple I and those computers, those early IBM compatibles, what they used to call them, those machines moved the computer from corporate business world, very expensive, to at-home knowledge generation. Okay, so to look a little bit deeper, now we can see where computers in your life now. Back in the 80s, a computer looked like a computer. Well, now when we have computers, we see that there are computers around you. You are probably addicted to a little small computer that you call a smartphone. And not to judge you, but most everyone these days has a smartphone and they live by it. Matter of fact, I'm recording this at the wee hours of the morning, and the first thing I picked up before I got out of bed, after I got out of bed, was my smartphone. So that smartphone, that's a computer. The television, the smart television that you have, that is a computer. And that's a different type of television than your parents had when they were growing up. It used to be a television only had one thing in it, and it was a screen. Now the television has a remote that can control things instead of just the channel, which is just amazing. You should marvel at your television. Televisions have enabled us to be far lazier today than we were years ago when we were watching television. But since we know these computers are everywhere, since these computers are all around us, we need to have the literacy to understand when you're interacting with a computer and to understand enough about computer systems to where, all right, so now that I know there's a computer in here, I can behave and interact with this in a certain way, which will help me be more successful than just pressing buttons and hoping to get what I was hoping to get. So that's computers in your life. Let's look at some of the computers that are in your house, in your home. Of course, computers are used for a variety of tasks. We can start with the very obvious ones, looking up information. So that's searching the web. That's Googling something, Binging something, exchanging email. Right. And then shopping, paying bills online, watching television and videos, downloading music, downloading movies, music videos, digital photographs, playing games, making vacation plans. I mean, this is a laundry list of things we do with computers at the house, but it continues on. It's used for reference, productivity, entertainment. Right now, we would consider what you're doing productivity use, wireless networking. Now, computers, since we wirelessly network computers, they can be used almost anywhere. Whether or not it's using cellular data or if it's using Wi-Fi, for the most part, that little computer, their smartphone, is connected the entire time it's on. And it's this type of connectivity that makes things smart. And smart just means that it does something more than its single use. It's not just a single use thing. It's smart. So traditional appliances have built-in computers now. There are refrigerators with touchscreens. I wouldn't buy one, but people have them. There are smart homes. And this is where the appliances, the HVAC, the different portions of the home are controlled either in the house or away from the house with a computer. And to kind of illustrate this, I'll just show you 3 different examples. You've got computer labs. People nowadays are growing up with computers. So, think back. When was the first time you saw a computer? I imagine you can't remember. I can remember the first time I saw a computer, and I'm not going to tell you that because I'm not going to date myself this soon in the course. But certainly the first time you saw a computer, that's a nebulous memory because they've been integrated into your school life since you were a wee one. Campus internet, wireless hotspots. Just to let you know, this first day of campus this year, the wireless was so bogged down, it was almost impossible to log in. And I think it's because everyone brings this technology with you. And, there's an expectation. When you have a computer, you expect to get on the internet. And, students are accessing it everywhere and distance learning. This is a great shot because we have a campus in Fort Knox. And this picture is looks very close to what some of the IVS courses are doing up there, some of the remoting, where we have our students who are also soldiers sitting in, taking the same classes that our regular non-soldier WKU students are, remoting in and bringing that large distance, that 90 miles, and shrinking that to the small classroom experience. Now we can move from in education to see how computers are making their way on the job, in decision making. When we say decision making, we're talking about information systems. So if you pursue not just the CIS, but actually pursue CIS as a major, we'll talk about how computers are integral to the decision making progress. Productivity. For the most part, we're thinking about products that just help you create the business documentation, the business reporting, the business tools to be successful. Off-site communications and authentication. And authentication is so important. We're going to look at privacy. We're going to look at security with computers in this course. And we're going to see how authentication changes the way we live our lives just to accomplish that. And then finally, some of the computers on the go. So we know we're encountering computers in every day of our life. Well, where do we see them? When we check out at a restaurant, we might see a computer kiosk. When we're running low on money, we go to an ATM to make a transaction. We get that money and we go to the store. And then when we buy something, that point of sale, we're working with the computer. And then if you're like me and you don't necessarily want to work with the sales clerk, you use the self-checkout, which is a completely computerized and automated system. And then finally, there are those authentication systems that we talked about, and the portable computers and mobile devices in our pockets. And these devices to help us navigate around, communicate with GPS systems, which are also driven by computers. So when we think about it, let's think about the technology box, the U box. So when we're talking about that restaurant scenario, you go in there and you use an iPad to order stuff. And there's an electronic menu on there. You can place and pay orders. You can provide resources. You're provided resources, and you can also kind of recommend things to other customers. So a scenario of just eating is now a computerized, a technological scenario, which it wasn't in the past. So we've talked a little about what computers are out there and how they're integral, how they're a part of our everyday lives. We've seen where they show up in the classroom. We've seen where they show up on the job. We've seen that they just show up anywhere in our lives. Let's talk about what a computer is and what it does. Okay, so a computer can be broken down into kind of 4 unique steps. First, it takes input. Sorry about that. It takes input. So we type in 2 numbers, number 2 and a number 5. Then we press enter or some key to tell it to start processing. So then the computer in this scenario is going to add those 2 numbers for us. So it's going to add 2 and 5. Then it's going to output it. And this is the part where we can make meaning of the processing it's done. It's going to output the number 7. And then if we wanted, we could save this output to use it in the future. So we can look at that as input, processing, output, and storage. And this is the information processing cycle. Now, in management information systems, we talk a little bit more about what that output really is. And we're going to look at what outputs we can get from a computer in this course, not in this chapter, but in the course. So keep that. This is a milestone moment in this course, because right now this 4 input, processing, output, and storage it's a big concept to understand, and start looking at how you are inputting, outputting, and processing when you're using computers, because it'll help you really frame what we're working on in this course. So now let's talk about data and information. Now, when you input something into a computer, you're inputting data. It's raw, it's unorganized. It can be text, it can be graphics, it can be audio, it can be video, but this is just random stuff. Now, information is different. Information is data that's been processed into something meaningful. And that's 2 things that are important. It's been processed and now it has meaning. It's not raw and unorganized, but it has meaning, forethought, a purpose. And that information is created through information processing. And this typically is when we're just converting data into information based on a model, a paradigm, based on something that we know we want to accomplish. So if we look at computers then and we look at them now, the computer as we know it is a recent invention. we look at the history of computers a lot like we look at the history of human beings. We talk in generations. And just like with human beings, each generation is characterized by something major. Now with computers, it's a major technological advance or development. So the first generation is kind of pre-computers or early computers. And this was computers that came around before the 1940s. It was an abacus, a slide rule, a mechanical calculator, even some punch card tabulating machines and sorters. And we'll look at punch cards later. So then after this pre-computer era, we move into what we call the first generation of computers. Now these are the macro computers. They're enormous. They had vacuum tubes. A vacuum tube looks like an incandescent bulb. And imagine hundreds of these, thousands of these, connected to a large machine that helped it do some basic computing. It used electricity and it created heat. Again, these things were huge. They are definitely not green computing solutions. They were names. There are some names that commonly associated, and it was two of the bigger machines, the ENIAC and the UNIVAC. And you can see that the VAC at the end is because it was a vacuum machine. But so that's our first generation. The second generation of computing came right afterwards, 1958 to 63. This is a very short window of time. We're talking maybe 5 years here. And the difference between this generation and the one before it is instead of vacuum tubes, these light bulbs, it used transistors. And they were smaller, they're more powerful, cheaper, and they didn't break as easily. So, and the difference in size between a vacuum tube and a transistor is about the difference in size between an incandescent light bulb and a paper clip. So you can see that dramatic reduction in size allows you to make this machine a whole lot smaller, make it run off far less energy. And of course, it'd make it more reliable because those tubes aren't going to blow. And we communicated with these machines using punch cards, magnetic tape. We didn't really have a keyboard. We had to put some type of physical media into the machine. So that's kind of the second generation. Now, something to keep in mind is that if we're just going to skip ahead to now, and the third and fourth generations were just quicker versions of what we were doing. But we did get, the microchip and all that stuff. But when we get to the fifth generation, we can see, and this is now into the future, these are these machines that are actually competing with us on game shows. Natural language, artificial intelligence, touch input, voice input. Does this sound familiar? The machines you're working with now have some AI. They have voice and touch input. They're very modern machines. So now the third and fourth generation, we didn't cover it, but it will be on the test. So make sure that you're doing these readings because I'm not going to give you everything in the lecture. I need to be sure that you are doing these readings and looking at this stuff deeper than what you're just hearing me tell you. So there's your first hint. If I don't cover it here, it doesn't mean it's not in the text. It's not on the test because it most likely will be. So we've talked about computers then and now. Let's demystify a computer. Let's open it up. Well, let's just look at what is the components of a computer. Now, computers, first, at their most basic level, are physical things, so they have hardware. And this is what the hardware is. This is a nice diagram. Kind of shows you everything that you're using typically to do your computing. And it gives you some good names to represent all of those pieces that you use when doing the computing. Of course, you know what a keyboard is. You know what a microphone is. You know what speakers are. You know a monitor when you see it. I'm pretty sure everyone knows what a flash drive is and a flash memory card and a mouse. But inside of this system unit, some people call it a tower. I've heard a lot of people call it a hard drive. It is not the hard drive. But inside of this system unit, we have a hard drive. have a disk drive, we have a card reader, and there's even more things in there. And we're going to understand what these things are so we can speak a same uniform language of computing. So if we dive forward a little bit, the hardware are the physical parts of the computer. Now there's hardware on the inside. That's the internal hardware. Excuse me. It's located inside the system unit, the main box. We have external hardware. This is located outside the system unit. And it connects to the system unit using wires, or sometimes it's wireless. Then finally, hardware devices are associated with all of the computer operations. And we'll talk about that in a little bit as well. So let's dive into specific hardware pieces. There are input devices. That's your keyboard, your mouse. That's how you get stuff into the computer. There's a wide range of those. You can see those in the book. There's processing devices that can perform calculations. That's the central processing unit. That's internal hardware. We'll look at that later. And then there's output devices. That's things that tell you the output, the results. Remember we just talked about it. Data input, processing, output. And the output is presenting the results to the user. How do we do that? We use monitors, we use printers, speakers, projectors. All these things let you know the result of your computing. And then we have some storage devices. So there's internal storage that we use inside the computer. It's a hard disk drive, CD drives, USB flash drives, all these things used to store. And then the part that makes computers as useful as they are to us are the communication devices. And they allow us to connect these computers to other computers to understand what's going on. And now we use modems, network adapters, routers, the whole kit and caboodle. Now, hardware is one half of this equation. The other half is software. And here's a good screenshot of Windows 8. It has a start button, screen. You have windows, you have dialog boxes. This is kind of the modern computing environment. I am an Apple user, but Windows is also, Windows is kind of the base of where this type of computing really became mainstream. So that's what software is. But let's talk about the different groupings of software. Now, the system software, which is Windows or OS X, that is the software that actually interfaces with the hardware, that makes the hardware do what it needs to do. It provides those base level instructions. Once we have that operating system installed, that operating system on there, then we can use application software. And this is the stuff that is specific. It does things that we want it to do at a particular moment in time. So this is word processing, creating letters, writing budgets, managing inventory and databases. So that's spreadsheets, editing photographs. That's our Instagram, scheduling appointments. That's Outlook. That's our calendar, viewing web pages, browsing the web, doing email, burning DVDs of appropriately gained movies you bought, designing homes, playing games. There is an endless list of examples of application software. The one you're probably most familiar with the exception of Instagram or sending text messages in terms of word processing, is Microsoft Word. And you can see here, this is a productivity app. It was built for productivity. So application software is not the software that interacts with the hardware, but it's the software we use to have the computer do something specific we want to accomplish. Multimedia programs, web browsers, email programs. And now that we've talked a little bit about the software, let's talk about the users. A computer user is an end user. And by end, we mean at the end of the production, the person who uses the computer. That's kind of an end user. So these are people who use a computer to obtain information. Computer professionals are people who who write programs to tell the computer what to do. So this is programmers, system analysts, they design computer systems. Computer operations people, they kind of manage the day-to-day operations of computers. And then security specialists, these are the people who keep the information in the computer safe against networks and hackers. So quick quiz. Which of the following was not a first generation computer? The PC, the UNIVAC, the ENIAC. Next question. True or false? A window displayed when the computer needs more information from the user is called a dialog box. And then finally, speakers are an example of an blank device. Take a moment to think about that. Well, I hope you were able to answer those questions. The answers are, for the first one, A, an IBM PC would not be considered a first generation computer. It is not as big as a football field. The second one is true. When a window is displayed and needs more information, that is a dialog box. We didn't cover that, but I hope you know that. And the third one, speakers are an example of a output device. So let's see the answers. Booyah. I hope you got those right. If you did not get those right, make sure you're doing that reading and make sure you're reviewing kind of this first half of chapter 1. Okay? So let's move forward. Computers to fit our every need. Well, there are many categories of computers, and they do fit in our lives differently. The first are embedded computers, then mobile devices, personal computers, servers, mainframes, and supercomputers. Now, let's dive into the first group. An embedded computer is something that is inside of a product that does something that you wouldn't associate with computers. They're not general purpose computers, but they're little bitty computers that are embedded into things like household appliances, thermostats, sewing machines, treadmills, you name it. Your answering machine is an embedded computer. And the most expensive embedded computer you probably own is your car. And you can see here that, within that computer, you have in that car, you have indicator lights. Some people have cameras located in the mirror. Obviously, the dashboard has some computing going on there for most cars. There's a little display. Computers all over the car. So an example of an embedded computer is a computer that does another function. The car's main function is to drive you around. It's to get you from point A to point B, but that computer's in there to assist in that function. So that's an embedded computer. The next group you're very familiar with, and it's mobile devices. A mobile device is a very small device capable of built-in computing. Typically has a small screen. This says and a keyboard. I don't agree that it typically has a physical keyboard, but it typically does have some type of keyboard-like input device. Some examples are smartphones, handheld gaming devices, portable digital media, tablets, you name it. I think mobile devices is something you're familiar with. We're not going to spend a whole lot of time there. So the next one is this personal PC. Now, this is a general purpose computer. Now, it's meant for one person to use at a time. We also call them microcomputers. Now, of course, they're not microscopic, but they are microscopic in comparison to those first generation computers, which all this terminology is based on. You can get them in different shapes and sizes. And then there are desktop computers that you put on a desk. Tower case, desktop case are all in ones. And in this example, this is a tower case here. The system unit that's a square, we consider that a tower. And then the all-in-one is where you do not see anything other than what appears to be the monitor for the actual computing platform. They come in two varieties, PC and Macintosh. There's also Linux, which is a third variety, but we don't really cover it in this book. And desktop computers are not that portable. Now, to contrast, we've got two desktop computers on the screen which are not portable, but we can take a look and see what some portable computers are. So These are small computers. You can carry them around. They're notebooks, they're tablets, they're hybrid notebook tablets. And, really the future is headed in this direction. Windows 10, which recently came out, is all about integrating this tablet functionality into a general notebook. So, this is that second set. We're still talking about PCs, but this is that portable version of these two desktops we saw earlier. We're all still microcomputers here. And then that next set is what we call thin clients. And these are machines that do all of its work, most of its work on a network. They're cheap, they're very secure, they're easy to manage. They don't have any storage on them, and they don't even work if the network is down. These are just really internet thin as in not a whole lot on them clients. Now we have internet appliances, which is a computer network designed for internet access, deliver news, sports, weather, you name it. Okay. Now all of this is still in that first group that we talked about. I'm going to go back and show you the slide of personal computers. These are all personal computers. Okay. So I don't want you to get confused with this being something other than a PC. They're different varieties, different flavors, but they're PCs. The next group are servers. Okay. Now a server is different. It's a bit stronger computer, stronger than a PC. It's not a super fast computer, but it's stronger than a PC. It's more considered a mini computer. And this server is the machine that allows clients to use a network. Some of them virtualize, which means creating small little versions of itself in software instead of actual. But the server provides internet. It serves up connectivity, whereas a client receives it. Okay. So that's a main group. After that are mainframes. Now a mainframe is a much more powerful version of a server. It's big. It's used by organizations like universities, large businesses, government offices. Typically these mainframes have to be cared for using a lot of expensive air conditioning units, different fire suppression units. They're climate controlled. Okay, they're larger, more expensive, and more powerful than servers. And these things have to be up all the time. So for example, Facebook, the software running Facebook is somewhere sitting on some mainframes. Okay. And most people, even with Twitter, you want to have access to it 24 hours a day, 2:34 a.m. on a Sunday. You want to be able to tweet if you want to tweet. And that's accomplished through mainframe computers. So that, 99.999% uptime, all that stuff through mainframes. Now that is not the end. The next thing we have are supercomputers. And these are the fastest, most expensive, powerful computers. They run one program at a time, and they do it as fast as they possibly can. They typically cost millions of dollars. Excuse me. Now, to contrast, there may be millions of dollars in mainframe computers that are all linked together. So more than one computer linked together. These supercomputers are just one large computing platform. They tend to be huge. They're, you can see this one here. This Titan is just a big piece of machinery. And they're fast. These things are super fast. They're so fast that you have to rent time on them to use them because the computing they do far exceeds the capabilities of a mainframe or a personal computer. Time for a quiz again. So a tablet PC is an example of what? A desktop computer, portable PC, an internet appliance. You tell me. True or false? The terms mainframe computers and supercomputer are interchangeable. They both refer to the largest, most powerful computers. And then finally, a smartphone is an example of a, and I want you to give me the answers. So take a moment. what are our answers? Well, the first one, a tablet PC is a portable PC. I hope you got that one. It's not a desktop computer and it's not an internet appliance, although we mostly use it for the internet. True or false? Mainframe computers and supercomputers are interchangeable. That's false. Mainframe computers, although powerful, do not come anywhere close to the power or the ability of supercomputers. And then finally, a smartphone is an example of a mobile device. So here are your answers. You can take a look at that. And again, if you didn't get all three of those, let's get into those readings and make sure that you understand. And these quizzes are examples of the type of questions you're going to get on the exams. So, a little insight. Now, let's look at computer networks and the internet. Here is a nice diagram to show you the interplay between your computer and a network. So we've got Betty's PC. Let's pretend like we're all Betty right here. So this is Betty's PC. Betty's PC takes files and she sends them off to Tom, but they go through a network server. Okay. Now, if Tom is someplace that is not directly notified, we go here, but we can send it directly to Tom, and then Tom can email it right back through that server and go to Betsy if he wants. Now, let's say that you were sending an email to tech support. Well, this would go up through the internet connection and hit the broader internet. Isn't it great that that looks like a cloud? Because a lot of times we refer to it as the cloud. And then when you search for a web page, the cloud serves you up a page, sends it to a local server, and then it comes to you. And then if you want to do this wirelessly, you can. Or here's a shared printer. So that's kind of a rudimentary look at a computer network. We're going to dive deeper to see what that really means and how it works later. So, networks exist in many sizes. We have home networks, school office networks, corporate networks, public wireless networks, mobile phone networks, you name it. And these networks, when we put them together, we get something called the internet. Now, the internet is the biggest network out there, and it is made up of other small networks put together. Okay. Now, the internet has something called the internet backbone. We cover that in the book. I want you to take a look at it. And people connect to this internet backbone using what is called an ISP, which is an internet service provider. On campus, when you live on campus, your ISP is WKU. If you live off campus or wherever you live, if the city you're in, if you're taking this remotely, you probably use someone like Time Warner, AT&T Uverse, Verizon, Fios. There's any number of internet service providers, and these are people who give you the connectivity to connect to the internet. Now, when we talk about the internet, for the most part, we're thinking about the World Wide Web, which is a resource on the internet, and it's a collection of web pages you can use to look up information. Social media is on the web, and so are television shows, YouTube, whole kit and caboodle. So that is the World Wide Web. And the way we access it is through a web browser. And this is a piece of software, whether it be Chrome, Safari, Firefox, that you use to let you interact with the web. So how do we access a network or the internet? Well, we need some hardware. We need that modem or that network adapter. We need credentials to get onto the network. So that's a username and password. And some of the connections can be, a wire directly plugged into the back of your computer, dial-up connections. I don't know how many of us are still using dial-up, but dial-up used to be all the rage back in the 90s, in the early 2000s. Now most of us are using broadband and internet addresses. And this is how we know where we want to go. We type this in and this gets us to our destination. Now, we have a couple protocols associated with that. We've got the internet protocol, which gives you an IP address. And this is like a physical mailing address for your computer, which is why we use the word email when we want to send from one computer to another. And it's just numbers. It's typically in this kind of 3-number dot up to 3-number dot 3-number dot 3-number. And that would represent one specific computer in the entire world. Okay. And if we want to break that out a little bit more, we can see how IP addresses and domain names interplay. So an IP address is the physical address of the computer. They're numeric, they're unique. But a domain name is something that turns that computer address into words that humans are better with. They correspond to a group of IP addresses. And then we have top level domain names. And then we have us. And what those do is they identify the type of organization. So you can see here, we have a .com for commercial, gov for government, mil for military. We got some new ones, jobs for employment sites, names for individuals. We just have a lot of variety. We have a lot of options here to name these individual computers when they're on a broader network. And to find out what, when you type something in, you just don't type in .com. You typically have some stuff before there, Google.com, football.com, Kardashian's TV show.com or whatever. So let's look at those. Now, we typically click through links, but those links really are URLs, Uniform Resource Locators. And uniform is in there all the same. Resources is in there pointing us at one computer or one group of computers. And locators is that they tell us the location. So we can break this out. We can see here the protocol. And the protocol we use for the web is called HTTP, Hypertext Transfer Protocol. And this is what the pages are displayed in. If we wanted to download some files, we'd use FTP, File Transfer Protocol. But both of these protocols are based on these uniform resource locators. And we can break it down into some specifics. The HTTPS, or this part at the beginning, describes what protocol we're using. So it lets the computer know, I want to see a website, so I'm going to HTTP. If I wanted to download a file, it would do FTP. Now, this next part of the URL identifies the server, the domain, and that is the .com portion. And that's probably the most critical piece of this URL. Next to the protocol, that domain is the most pretty important. Next is the folder on the server that we want to visit. That's what those slashes do. They take us from one folder to the next. And then finally, the name of the file that we want to retrieve, or the name of the document. So right now you've been decoding. You've been giving very specific locations on the internet when you surf, and you may not know you do it because we're just very used to typing in something.com/something else. Now, that is for URLs. Let's look at how email addresses work. Well, they consist of the following: a username, that's an identifying name, an @ sign, and this breaks it up so the computer can read it, and then a domain name for the computer that will be handling the person's email, the mail server. And the way we pronounce it, we have the domain name, URL, and then an email address. So you can see, if we were to pronounce the domain name, it would be berkeley.edu. We're just going to spell out what's afterward. The URL, microsoft.com/windows/IE/default.asp. And then an email address would be president@whitehouse.gov. So that's kind of the language again. That's how we would say these things out loud. How it works? Well, let's just take a look. Let's say we want to send out an emergency campus notification, a system built around that. It would enable students to be notified if issues were happening. So we'd have some people, emergency personnel, who would be able to send messages, email, Facebook, the whole kit and caboodle, and digital signage directly to whatever device that is you choose, using these domain names to receive this information. If you're on campus, you probably were asked if you wanted to use your phone for the emergency campus communication. I hope you chose yes. But this is one of those examples where you can send messages out using these different protocols before, and it manifests in these different ways in our small computer systems. Now, to surf the web, you need a browser. You use it to display pages. A home page, that's where you typically start. Most people's home pages might be Google or Bing. I don't even know what my home page is, because when I open up my browser, I go right to that address bar and start typing. You use it to navigate a web page. And like I said, you can use the address bar for the URL. You can click a hyperlink or graphics in linked text. A lot of times I'll start my surfing sessions by clicking a link in my email, and that'll open up the browser for me. And then you have a favorite or kind of a bookmark, well, not kind of, bookmarks or whatever, or history list where you've been before. To show you how we search the web, you go to a site that helps you find what you're looking for. And this is a site that connects human language to actual other websites. You use keywords, that's that human language. And there are reference sites. So you can look up numbers, telephone numbers, maps, restaurants, the kit and caboodle. Now, we talked about searching the web. Let's talk about email again, how it kind of works. Email, we go from the sender's computer, and then from there we send it out. It's going to go to the mail server, hit the recipient's mail server, and then it's going to go to the recipient's computer. So you can see just one email is going to travel through two different servers. This center section is a host of different network computers. So, when you think about this internet, everything we do on the internet is a bunch of computers working together, working for one common goal, and that's our communication. So email is electronic mail. You know that. It's one of the most widely used internet appliances. It can be a conventional email machine, web-based or mobile-based. And just the difference between the two, Outlook is a conventional email program. Gmail is web-based. OSXmail is a conventional. Outlook.com is web-based. And the way you think of this is software on your computer, where these are websites. And to dig a little deeper, email can have photos, attached files. Some email may require a fee. That's not common very much anymore. It may be again in the future. There are other types of small communication. There's SMS, MMSS. On most modern phones, you can't tell the difference between these two anymore. The MMS and the SMS are about the same. Computers in society. Let's talk about some of the impacts. And just to recap, we have covered quite a bit. We started looking at the basics of computers. We looked at the different types of computers, ranging from embedded computers to mainframes. We talked about the generations of computers. First, second, and fifth. We covered 3 and 4 for you to learn on your own. We talked about phrases like microcomputer, mini computer. We talked about turning data into information. We have covered so much that you really need to spend the time reading this to make sure you are strong on this basic information, because the whole course is constructed around these competencies. So at this point, let's talk about the impact of computers in society. We're not going to spend a whole lot of time. We're going to go through this fairly quickly, and then we'll wrap up. So, computers in society, they've changed the society. They've made a distinct impact on our daily life. There's so many benefits for being a part of a computer-oriented society. We can design products. We can make better construction. We can create better medical devices, give people more effective treatment. We can have devices that can allow physically and visibly challenged people to perform tasks, accommodations. We can send email and communicate in moments. We can download things. Entertainment is off the charts nowadays. Everything we want is on demand. Computers have also helped us release stress. Now, it has risk. We do have spam. We have computer viruses. There's identity theft. There's privacy, how data is collected. So if you think about it, it's a double-edged sword. The impact on computers has been very positive in the things that it has helped us accomplish as a species. But it has also increased the ability for those who want to do wrong more efficiently.